We're going to continue our topic of simplifying radicals, but now we're going to start to include adding and subtracting radicals. So when we have an expression where we're adding and subtracting radicals, the first thing we need to do is simplify any radicals that need to be simplified. Then we're going to add or subtract the coefficients of the terms where the radicand is the same. So if we have the same radicand, such as these both have a radicand of 2, this one's 3, that one's not the same. If they have the same radicand, we can combine their coefficients. The operation here is addition, so we've got 3 plus 4, which is 7, keep the root 2, and then minus 2 root 3, because we couldn't combine that with anything. So again, the radicands have to be the exact same if you want to add or subtract them, and then just add or subtract their coefficients. Don't change anything about the radicand. Here we've got 3 root 6 minus 4 root 6. They both have a root 6. That root 6 does not need to be simplified because the only factors of 6 are 3 and 2. Those are not perfect squares. So we can look at the coefficients. 3 minus 4 leaves us with -1, so we have negative root 6. Number 2, both of the radicands are 7. The 7s cannot be simplified, so now we look at the coefficients. -3 plus 4 is 1, so we're left with just root 7. Now we have radicands of 21. The factors of 21 are 1, 3, 7, and 21, which are not perfect squares, so now we just look at the coefficients. -11 minus 11 is -22. Keep the root 21. In these examples, we are going to have to simplify some stuff before we try to add or subtract, before combining like terms. So, in this one, our first term has a radicand of 3. That can't be simplified. The 27, let's check. The factors of 27 are 1 and 27, 3 and 9. So we can do 3 and 9. There's our perfect square of 9. So we've got a pair of 3's that we're going to take to the outside. If there's something that's already there, we'll multiply them together. Whatever's left over stays on the inside. So now we still have -2 root 3 at the front, plus 3 times this pair of 3's. 3 times 3 is 9. And then we have root 3 because that was left over. And now we can combine the coefficients. -2 plus 9 is 7. Keep that root 3. In number 5, we have -3 root 20 minus root 5. The 20 can be reduced to 4 and 5. There's our perfect square, 2 and 2. We're going to multiply the 2 and the -3. So now we have -6 root 5, because we had that 5 left over, minus another root 5, leaves us with -7 root 5. Number 6, there are a few things that we're going to have to simplify. So let's do all of the simplification first, then we'll combine whatever we can combine. So 18, the factors are 2 and 9. 9 has a factors of 3 and 3. So now we have -9 root 2. Because this pair of 3's, we multiplied by the 3 that was already there. 2 stays on the inside. Then we have 8. The factors of 8 are 4 and 2. Factors of 4 are 2 and 2. We have a pair of 2's and another 2 left over. That pair of 2's times 3 gets us 6 root 2. And then with our 24, the factors of 24, we can use 4 and 6. 6 has 2 and 3. 4 has 2 and 2. There's a pair of 2's. That's going to go to the outside. So we have -2. And then whatever's on the inside, remember if I said that there are multiple things that need to be left over, we're going to multiply them together, so this is going to stay a root 6. Now, the only radicands that are the same are the ones with the root 2, so those are the only ones we can combine. This -2 root 6 is not going to change. So now -9 plus 6 gives us -3, keep the root 2, and then -2 root 6, and that's our final answer for that one. Now we have this challenge problem. It's got some bigger numbers, which we need to simplify first. So we've got 48. Factors of 48 are 4 and 12. Factors of 12 are 4 and 3. We could find the factors of 4 and have 2 and 2 and then another pair of 2's, Or we can say, wait, I've already got this pair of 4s. I don't need to do any more work. So I'm going to multiply 4 times 8, which is 32. Keep the root 3. And move on to the next term. 75 has factors of 25 and 3. 25 has factors of 5 and 5. Then we're going to do 5 times that negative 6. So now we have minus 30 root 3. And then finally 80 can be reduced down to, we can do 8 and 10. 8 can be 4 and 2. 10 can be 2 and 5. 4 can be 2 and 2. So here I have a pair of 2's and another pair of 2's and then this 5. So since I have 2 pairs of 2's, I'm going to multiply each one and then multiply by the 7. So 2 times 2 is 4, times 7 is 28. So we have plus 28, and then we have that root 5. And now we can combine like terms. There are only 2 things that have the same radicand, so those are the only ones we can combine. 32 root 3 minus 30 root 3 is 2 root 3, and then we still have the 28 root 5.